Now let's look at rational inequalities. So a rational inequality looks just like a rational equation, which this is a rational equation right here, the equal sign. The rational inequality looks just like a rational equation, except we're using an inequality symbol instead of the equal sign. So a rational function, remember, is any function that involves a fractional representation, and we know that negative exponents are as well. So a negative exponent or a fraction like so would be a rational expression. All right, let's solve this. Now, the first thing that we do when we look at this, x minus 3 over x plus 2 less than or equal to 5, the first thing that you might think to do is multiply the x plus 2 to the other side. Here's why you should not do that. Remember when I'm multiplying or dividing an inequality, if I multiply or divide by a negative number, I'm supposed to flip the inequality, change this direction. But I don't know whether x plus 2 is positive or negative. So if I multiply this to the other side, I don't know if I'm supposed to keep the inequality or flip it around. So we never do that. What we do instead is get everything on one side of the equation. So I'll subtract 5 and get x minus 3 over x plus 2 minus 5 is less than or equal to 0. And then get a single fraction by getting a common denominator over here. So this is 5 over 1. So my common denominator, the least common denominator, would be x plus 2. So I'm going to multiply the 5 over 1 by x plus 2 over x plus 2. So I'll have x minus 3 over x plus 2 minus 5 times x plus 2 over x plus 2 less than or equal to 0. Now I'm adding two things with the same denominator. So we add the numerator, keep the denominator the same. So this is x minus 3 minus 5 times x plus 2 over x plus 2. And then distribute the negative 5 through, x minus 3 minus 5x minus 10 over x plus 2. And then let's go ahead and combine like terms here. So the x minus 5x is going to give me a negative 4x. And then the minus 3 minus 10 will be minus 13 over x plus 2. And this is less than or equal to 0. All right, now, if it's less than or equal to 0, that would mean it is 0 or it is negative. So I'm going to identify the two places where it's 0 or undefined by setting the numerator to 0 and setting the denominator equal to 0 and solving each of those. So this is x equals negative 2, and this would be x equals negative 13 fourths. All right, now we go ahead and plot those on a number line. So the negative 2 and negative 13 over 4 would be, negative 13 over 4 is negative 3.25. And the negative 2 is here. So we test the sign of everything in between. So I pick something less, like negative 10. 40 minus 13 is positive. Negative 10 plus 2 is negative. Positive over negative means the expression is negative here. In between the two, I can pick negative 3. 12 minus 13 is a negative 1. Negative 3 plus 2 is a negative 1. A negative over negative makes a positive in here. And then over here I can pick 0. Negative 13 over positive 2 is a negative, so we're negative over there. So where is it that we're less than or equal to 5? In this region and this region. So that would be from negative infinity to negative 13 over 4. And then I have an equal here, so I'm going to include that point. And then again over here from negative 2 to positive infinity. And you want to put the bracket here, but remember this came from the denominator, so it can't be included as part of the solution since it would make the expression undefined. Let's verify that with our calculator. So if I go over here and I graph x minus 3 divided by x plus 2, that's supposed to be an x minus 3 divided by x plus 2, and then I graph 5. Notice that the graph is below here, and everywhere over here. So up to this intersection point, let's find that by hitting second and calc. And I want the intersection 5. And we want to say, yes, that's my first curve. And then second curve, yep. And then give it a guess to start approximating. Oh, I didn't move to the right one. So let's try that again. So second, calc 5 to intersect. So I have to move over far enough on the curve to get over to this other branch of the curve. There we go. So enter, that's our first curve. Enter, that's our second curve, the y equals 5. Give it a guess to start approximating, and it tells me negative 13/4. So up until negative 13/4, I'm less than 5. And then again over here, which we know comes from the 0, the denominator makes that vertical asymptote. So from -2 to infinity. Exactly the solution that we have here. So to solve a rational inequality, rewrite it to get 0 on one side and combine into one big fraction. Set the numerator and denominator equal to 0 and plot them on a number line, then test values. Let's look at this. This is already bigger than 0, so I'm just going to completely factor the top, x times x minus 2, and factor the denominator. That'll factor into x plus 5 times x minus 2. Okay, now, if I set the numerator to 0, I have x equals 0 and x minus 2 equals 0. If I set the denominator to 0, I have x plus 5 equals 0. And x minus 2 equals 0. That's exactly this solution. It's repeated in the numerator and the denominator. So it is an undefined point on the curve, but since it appears in both the numerator and denominator, I'm not going to expect to change signs across it. So -5, 0, and 2, we plot here. Pick something less than -5, like -6. -6 minus -2 is negative, negative, 4 negatives make a positive. In between, I'll pick -1. Negative, positive, negative, 3 negatives make a negative. Bigger than 0, I'll pick 1. Positive, negative, negative. So that's 2 negatives, that makes a positive. And bigger than 2, I'll pick 3. Positive. All right, we wanted strictly bigger than 0. So that happens here and here. And since there's no equal sign, we don't include the endpoints. So negative infinity up to -5, union 0 to 2, union 2 to infinity. Why did we break it 2? Because remember, we're undefined there, so we're not including that as part of the solution. All right, let's solve this rational inequality. Now, remember the first thing that we do is get a 0 on the other side. So we're going to go 1 over x minus 1 over x plus 2 minus 3 is less than 0. Now, my least common denominator here, remember this is 3 over 1, would be x times x plus 2. So I'm going to multiply this first fraction by what it's missing, which is the x plus 2. This one by what it's missing, which is just the x. And then this one by what it's missing, which is both terms. All right, now let's combine into one big fraction. I have x plus 2 minus x minus 3x times this x will be 3x squared, minus 3x times 2 is minus 6x, all over that common denominator of x times x plus 2. This is less than 0. Okay, now let's combine in the top. We've got negative 3x squared. X minus 6x. And then just a plus 2. Now to make it easier to factor on us, I can take out the negative, put it in front of the fraction. 3x squared plus 6x minus 2. And if I look at this, my I can't easily factor 3 and 2 to make a 6 in the middle when I'm subtracting. So we're going to go ahead and use the quadratic formula to solve. 3x squared plus 6x minus 2 equals 0. So x would be negative b plus or minus the square root of b squared minus 4ac over twice a. So that would be negative 6 plus or minus the square root of, that would be 24. 24 added to 36 is 60. So I can take a 4 out of this. And I'd have negative 6 plus or minus 2 root 15. 4 times 15 is 60 over 6. Or negative 3 plus or minus root 15 over 3. When I divide a 2 out of everything. Okay, remember we also need the zeros of the denominator, which are 0 and negative 2. Okay, so 0, whoops, that should be negative 2, and then 0. And we need an approximation for this value. Negative 3 plus root 15, that's almost root 16, which is 4. So negative 3 plus 4 would be 1/3. 1/3 would be around over here. So negative 3 plus root 15. And then negative 3 minus 4 would be negative 7 over 3. Negative 7 over 3 is a little more than negative 2, so it would be right over here. So negative 3 minus root 15 over 3. Oh my gosh, so we've got to test all these intervals. So I'm going to pick a number less than that, so like negative 10 will work. Now I'm going to plug into our expression here. That would be negative 300 plus 60 plus 2. That would be a negative, negative, negative. 3 negatives make it negative over here. Now, in between here, we're getting a little tricky because remember I said this is really close to negative 2. So I want to pick a number that's going to be for sure between these two. So I'm going to pick negative 2.01. So negative 2.01, this would be negative, and this would be negative. And then if I plug in here, that's about 4 times negative 3 is negative 12 plus plus. So that would be a positive up here. So a positive, negative, negative, make it positive. All right, in between these two, I can use negative 1. So negative 3 plus 6 plus 2 is positive, negative, positive. 1 negative makes it negative. In between these two, again, I want to pick something that I'm sure is in between these two, so I'll pick 0.1. So positive, positive, but this would be negative 0.03 minus 0.6. So, and then plus 2 would be a positive. Okay, so positive, 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 it's positive here. Now bigger than this, I can pick 10. Positive, positive. Negative 300 minus 60 plus 2 would be negative. Okay, we wanted it to be less than 0, so I want to pick the negative signs. So my interval would be negative infinity up to negative 3 root 15 over 3 minus root 15 over 3. Then again from negative 2 to 0. And then again from negative 3 plus root 15 over 3 to infinity. And I'm going to have parentheses around everything because there's no equal here. And if there were, I'd still need to exclude the zeros that came from the denominator.